Hello, everybody, and welcome to the session where we'll talk about how to unlock your mainframe and IBM data for the data lakehouse with Precisely and Databricks. My name is Ashwin Ramachandran, and I'm a senior product manager at Precisely. Now, let's start the discussion today by talking about why this data matters. Why does a mainframe matter? Why does a system like an IBM matter to your business? Now, one of the key pieces I'd like to point out here is data that lives inside of some of these traditional or legacy systems, be they a mainframe, an IBM server, legacy data warehouse, a relational transactional database. They continue to adapt and deliver increasing value with each new wave of technology. So if you're, say, an insurance company and you're doing a lot of claims processing, that claims data is a treasure trove of information that you can't afford to not analyze, that you can't afford to not include as part of your ML models as you start to try to be more predictive about your business. Now, when you look at the systems themselves and some of the key trends in the market, one of the really astounding facts here is over 70% of executives continue to see their mainframes and IBMIs as extremely important because they have customer-facing applications that depend on those platforms. Now, if you look at the mainframe specifically, many people sometimes think about the mainframe as this long-running platform, not necessarily gaining importance over time, but it's actually the opposite. In fact, in 2019 alone, the transaction volume on mainframe systems grew 55%. Again, more data, more potential insights, and it's valuable that you mine those insights. Now, in terms of these legacy systems as a whole, when you step back and take a look at the larger picture, one of the really interesting facts there is, over the past decade, there's been over $1.5 trillion of enterprise IT spend to support analytics workloads and things like that in some of these legacy platforms. So the key point that I'm trying to make here is while we talk about these and sometimes term these platforms as legacy, they really are key critical drivers to business success. And moreover, harnessing that data in your data projects is more and more important than it's ever been before. Now, why is it more important? Well, a couple of reasons. Number one, when you're actually able to unlock this data, that leads to enhanced BI and more complete analytics. So again, let's say you're a bank now. And as a bank, your job is to perform some sort of or build some sort of AML or anti-money laundering application using some machine learning techniques. Well, the key thing that you're going to need to harness and get is actual transactional data. Sometimes it may require you to pull that data as it's generated. When you talk about something like an ATM transaction or a credit card swipe, more often than not, that transaction is going through a mainframe system. So to actually build more comprehensive BI and more comprehensive analytics, or even machine learning projects for that matter, the key piece here is to make sure you're unlocking that legacy data so that can be properly combined with the rest of the data you're collecting in your organization to get more complete, holistic insights. Now, as a result of that, just the natural follow-on is when you include this legacy data and unlock it, you're getting just improved data delivery. You can discover more about your business, ask better questions about your business, and base the answer to those questions on the data. Now, again, when you're actually unlocking this data, one of the key challenges or one of the key things to keep in mind is, as I democratize my data, how do I do that in a way that's secure, is going to provide the types of governance and lineage information that I need? And this is vital. Again, your decisions and your business insights that are based on data are only as good as the data that's feeding those insights. And having that clear line of sight is really, really important when unlocking that legacy data. And then again, like we've spoken about, once you've really harness all of the data at your disposal, you're actually able to fuel more projects based on it. So with that said, I'd like to talk a little bit about what we've precisely bring to the table with our solution Connect. And Connect really is the best solution for accessing and integrating this type of data with cloud frameworks in real time. So we can efficiently and quickly connect to a variety of platforms, whether it's mainframe, relational database, or other. integrate that data and do it in a future-proof way so that you can design your pipeline once and deploy it in any environment. So as you build and mature your integration architecture, or as you build and mature your data architecture, your integration architecture is along for the ride, and you don't need to redevelop things. As a result, development times are reduced from weeks to days. And that's just because with Connect, users have a graphical interface. They can pull that data from the graphical interface, deploy it in whatever environment they need. And the last piece here that Connect offers, going back to that key challenge we talked about before, is security and governance are also along for the ride with Connect. So users can securely transfer their data, get the appropriate level of data lineage that they need, especially as that data moves from system to system. Couple that with our unrivaled scalability and performance, and you have an enterprise solution for integrating your most critical data assets with your critical machine learning platforms. Now, together, Precisely and Databricks give a great and pose a unique offering for our customers. On the Precisely side, we have over 50 years of experience in unlocking data from some of these legacy data sources. We know it, we understand it, we can deliver that data within the tight SLAs that are required. Users can build these visual data pipelines. They can modernize their batch ETL processing at scale, leveraging our high-performance engine. And we also do have change data capture capabilities so that users don't necessarily have to do full data refreshes multiple times a day. Now, Databricks is a fantastic partner because with their unified data analytics platform, Databricks offers 10 to 100 times faster core engine processing on petabyte scale data compared to open source Spark. Databricks has the lowest TCO through its auto-scaling and auto-configuration capabilities, which stands in contrast to some of the other platforms that are on the market today for machine learning and advanced analytics. And Databricks brings to the table this unified collaborative experience for both data engineers and data scientists all on a single platform. So when you couple what Precisely brings to the table with our high-performance connectivity and data transformation capabilities, and what Databricks brings to the table with this scalable platform that we can deploy our workloads on in a scale-out fashion, you can begin to see why delivering this data inside of these tight SLAs in a future-proof way becomes so compelling. Now, at a high level, Connect and Databricks work very closely together. So on the Connect side, all we do is we just pull in the data from a variety of different platforms or sources. Like I said, if you have data residing on a mainframe, whether that's in a flat file, a VSAM file, an IMS database, a DB2 database, we have capabilities around data extraction, but also data CDC on that data or change data capture around that data with a minimal footprint, highest performance engine on the market. We can also collect data from a bunch of different relational databases, an enterprise data warehouse. We can ingest data from things such as flat files, XML files, JSON, or even some sort of system like Hadoop HDFS. We can pull streaming data in from Kafka, and again, deploy on any cloud environment you need, or connect to data sitting in any cloud environment such as AWS, Azure, or Google Cloud Platform. Now, Connect, again, like I mentioned before, is natively integrated with Databricks. So we can leverage Databricks to do this data ingest. We can do large-scale data transformation, cleansing, merging, all of that done in the Precisely engine running on Databricks. And finally, because we're natively integrated with Delta Lake, we can deliver that data into Delta Lake with our native high-performance connectors. A user never has to worry about how that pipeline they built is actually going to be deployed and running on the Databricks platform. Instead, they focus on the business task at hand and the requirements of their integration. Precisely and Connect take care of the rest of it for you. Now, again, once that data is served in Delta, there are a variety of different architectures customers can deploy, maintaining raw data layers, bronze layers, silver layers, gold and rich layers. But we can always, again, natively load that into Delta and that can serve further reporting. BI and machine learning applications can be built on top of it too. Now, diving one step deeper in terms of our connectivity here, again, really what we're offering is the ability to get that data from these legacy platforms natively loaded into Delta Lake. And Connect does that through our wide variety of connectivity, again, accessing things like vSAM data, mainframes, flat file data, DB2 data, coupling that with our design once, deploy anywhere approach that doesn't require any sort of data staging. That really allows us to ensure that data is delivered within the timelines that it's required. From a compliance perspective, we have a lot of customers who are in more regulated industries such as financial services and insurance, and oftentimes there's a requirement that the actual data is preserved in the cloud in its original format, in a bit-by-bit format. And what we can do is we can comply with that and preserve that data, even if it's complex vSAM data or variable length mainframe data in an EDCITIC encoding. We can actually take that data, store it in the cloud in its original format, but again, make that data available for processing within Databricks. So you leverage Connect to do that large-scale data transformation into a format that the machine learning applications running inside of Databricks can understand. And again, from a lineage perspective, we can provide really granular level detail as to what data was touched, who touched it, how did they transform it, and how does the metadata propagate throughout the integration pipeline. Now, the last piece I'll mention here is performance. Performance is something we really pride ourselves on and we really focus on. Our self-tuning engine automatically ensures the best performance for complex things like joins, data aggregations, data transformations, and coupling our native vertical scalability with the horizontal scalability of the Databricks Unified Data Analytics platform really ensures that data can not only be delivered, but it can be delivered within the tighter and tighter SLAs that the business demands. Really, users can break down data silos and start operating on data in minutes. So to show you that, what I'd like to do is step through a little bit of a demo showing you how Connect works in conjunction with Databricks to move data out of the mainframe into the Databricks Unified Data Analytics platform. So let's start off by showing you what our interface looks like. Here, I'm building a data pipeline where I'm merging multiple data sets together, a lot of it originating from the mainframe. But my goal here, and what we'll show you, is how I can load that data into Delta Lake. So in this job, as we call it, there are multiple different steps. The first steps start out by pulling data off the mainframe, combining it together, and then loading. So really simple kind of extract, transform, load process. So to begin with, for a mainframe file, for a mainframe fixed record length file, I associate a copybook. Connect natively understands COBOL copybooks. You can link to it directly within our editor here. And once you actually link it in, all of the different COBOL fields are automatically translated for you to a format that even someone who doesn't understand the mainframe can interpret. So here we can deal with things like occurs depending on, redefines, and packed decimals. Now here I define my source file, and in defining my source file, I select the actual location where that lives. I can pull that data directly off the mainframe if I so desire, and if I need to, and then define the record type. So here I've chosen a fixed record length type, but you could choose a vSAM or something else. Now here you can see the data is encoded as EDCITIC. Connect supports all of the different ICU code pages. So if you're using a non-standard EDCITIC code page or an international EDCITIC code page, we understand how to deal with that. What I'm going to do now is show you a little bit of the data sampling we have, and you can actually see the data. The data you're looking at on the screen here is raw mainframe data, but Connect is interpreting it for you and showing it to you in a displayable form to make integration easy. Now with that, it's just a matter of defining a target. I'm going to just take that file, transform it according to the data definitions in the copybook, and I'm going to transform it and load that into Databricks. So this will actually go into Delta. I've provided my JDBC URL, leverage the authentication that's there in the Databricks environment, and that's pretty much it. Now I've fully defined a transformation process from mainframe all the way into Delta in a couple clicks. Now you can always add other database tables if you wanted to, add more Delta tables fairly easily. And when you want to do that, what you can do is just open up that dialog. We'll list out all the different tables inside of Databricks, select the table you need, and then we try to auto map everything for you as best as we can. So here you can see I've auto mapped fields to a new target table. You can define how you want to map them. You can provide or put in individual field level transformations as well. And additionally, you can optionally filter data. With mainframe data, it's often the case that data will be taken from a single file, and because it's stored in a hierarchical format, oftentimes users will split that data out into multiple relational tables. But with that, I can now run this job. I can actually now run that job natively inside of Databricks. You can, again, with a single click of a button, you don't have to define the low-level details. You just select the actual framework and then run the integration process. So here I'm going to load that data in. Once this finishes running, we'll be able to take a look at that data sitting inside of Databricks. Now we're going to quickly show you some of the statistics. And these statistics are very useful for users to better understand any potential issues that were discovered in the data, any failed records that failed to load, data volumes read in, written out, all that is available in the statistics for you. So you can see I read over 1 million records, I wrote out over 1 million records to Delta, and then if you go into the Databricks environment, you can now see those tables that we loaded into, and you can start exploring the data within there. Again, within 4 minutes, we just took a complex EBCDIC encoded mainframe file and loaded that into Delta. Now that data is ready and waiting for more data refinement, cleansing, enrichment, and beyond that, some real intense machine learning processes as well. So with that, really, we've talked about how Connect and Databricks work together. So what I'd like to do next is talk about a customer story that shows business transformation in action. Now, this is a customer story around a global insurer with the goal of digital modernization. Now, they had a top-down initiative to improve their NPS scores, improve their operational efficiency by digitally transforming their claims processing. Much of this claims processing runs on the mainframe or ran on the mainframe at the time, and they wanted to take that and modernize it with a couple key outcomes in mind. They want to improve the claims experience for end customers, again, helping with things like such as NPS scores. They wanted to use some machine learning to identify certain patterns in the claims data that would alert the business to unexpectedly severe claims. And then lastly, they wanted to automate some of the fast tracking of low dollar claims without the need for an adjuster to manually get involved. So as you can see, this mainframe data housed all of these claims. And what they really wanted to do was unlock that data, make it available in Databricks so some of these other use cases could be enabled. Now, with the problem statement defined, that was a great first step, but there are a couple of key challenges when it comes to integrating this data. And the main one that really sums it up here is their existing methods of integration were inefficient or really unable to successfully even connect to integrate and deliver that mainframe data in the way I just showed you. So they needed a way, or they needed a solution that was going to allow them to successfully and reliably migrate this claims data for thousands of clients. I mean, these are tens of thousands of clients moving all of that data into the cloud for this comprehensive ML. Now, another key challenge was, for anyone who's worked with mainframe data, you're very familiar with the way metadata works in that environment. You have things like COBOL redefines, repeating nested arrays, COBOL high-low values, EBCDIC, pack data. The key challenge was dealing with those kinds of data types and translating them into something that was going to work inside of Delta and inside of Databricks. And so what they needed to do was, as best as they could, leverage the existing metadata they were leveraging on the mainframe. This would allow them to simplify their integration pipeline, but also, more importantly, maintain source to destination lineage visibility. So by leveraging the existing COBOL copybooks or existing metadata on their mainframe, they would be able to more easily integrate their data, but also provide that clear line of sight for compliance purposes. And the last key challenge here, scale with growing data volumes. Like I mentioned before, we're talking tens of thousands of clients here. And so the amount of data was a key challenge. They needed a solution that was going to scale. So together, really, Precisely and Databricks were able to help build this high-performance data hub for machine learning, for analytics, and they used Connect and our ETL capabilities within Connect in conjunction with Databricks to achieve this. Now, the key results here, not only was the data delivered, but there was no downtime or rework for implementing this new approach to legacy integration. They were able to take some of the existing pipelines that had deployed with Connect in a non-Databricks environment and then just port those over to run natively inside of Databricks. This would get coupling the vertical scalability of Connect with the horizontal scalability of the Databricks platform. Another key piece here was they were able to meet the high volume requirements of their hub. And then ultimately, going back to that business problem, they were able to deliver on those key goals, making the claims experience faster and improving the overall customer experience. So again, here's an instance where there was a key business objective and a key business directive that directly relied on being able to handle, access, integrate, transform, and deliver legacy data that was still being generated on the mainframe. So I'd like to close this session by just touching on a couple of takeaways for success. The first thing I would suggest, learning from this customer, learning from some other customers that we've worked with, is ensure that the goals of your modernization efforts are clearly defined. What's the end state vision here? Are you trying to save costs? Are you trying to improve performance of an existing pipeline? Or is it something else? Is there the opportunity to deliver data in a more timely fashion to gain some sort of business competitive advantage? The next point I would say here is ensure that you're choosing an integration solution that's going to easily allow you to expand for new use cases. So today, this customer is doing this batch data movement, but as business needs change and evolve, if they have new requirements, say around real-time data delivery, or if they have some new requirements around how data needs to be integrated within Databricks, they're able to leverage their Connect investments to expand to new use cases. Now, another thing I would call out here, especially as organizations go through this modernization, is some of these new requirements for the cloud platforms may break current data integration architectures. And really the key message here is don't lock yourself in too much. You want a solution that's going to be flexible enough to solve for today, but allow you to embrace tomorrow as it comes. And then again, the last thing I would highlight here, and this really relates to a lot of Precisely's customers that we work with, is select a tool that's going to allow you to solve your integration problems across the hybrid landscape, from data center to public cloud. So the example that I shared with you just now is a great example of an integration architecture the customer selected to solve for these hybrid problems. As it stands, that mainframe system that's housed in the data center is not going away anytime soon. It's going to continue to power the business for its key areas of differentiation and success. And so the challenge of the organization is to ensure that data can freely and securely move across the hybrid landscape. And that's a key thing to make sure you're solving for as part of your integration architecture. So with that, I'd like to thank you for joining this session, and we'll take any questions.